improving organic matter by a regular chemical test. Is that really what you want to do? You know, some compost may have good contents in that compost, some may not have much nitrogen, so you got to be careful what kind of additions you put on your soil. Yes, you can say I'm improving my organic matter, but it may work against you if you're not improving your active carbon part of that. Because if you don't, you may be using up a lot of the nitrogen. It may actually hurt you more than it helps you. So you got to get the right source, the right content into that organic matter that the plants can utilize and get the energy out of it. That relates to better crop production. So that's what we're all about with that. So what's the benefit of improving organic matter? We've been talking about water content with irrigation, right? So these three lines are three different soil types, basically sand, silt, and clay. And this is percent organic matter. So no matter what your soil type, the graph increases. This is the available water content. So what's that telling us? No matter what kind of soil you're given, if you can add organic matter to it, you're adding that sponging effect that organic matter has, and you can hold more water content in your soil. Now, is that good in a wet year? Well, if you have a spongy material, it should release water as well as absorb it. You have good structure, it self-drains it better too. So it doesn't hurt to have more organic matter even in a wet year, because it'll naturally filter out through the soil content. So our goal should be trying to move across this line of percent organic matter, because the year that we talked about, you know, 02, 2012, it's going to happen, guys. You know, we get good growing years, we get average, and we get terrible growing years, right? You can't predict it. You build up your organic matter, you have a little bit of insurance there that organic matter will hold more soil moisture when that crop needs it when you're under stress. And it won't hurt you in a good growing year. So we should focus on that above anything else, above fungicides, insecticides, even nitrogen. This is more important than any of those put together, because think about a drought year. You do all those things in a drought year, is it going to make any difference in yield? No, the only thing that makes a difference is water. You got to have water, and that's the primary ingredient to good yield. You get your water by holding it in organic matter. So I might as well quit now, right?
And Alan mentioned a good point. 1% in organic matter, that means 1,000 pounds of nitrogen in organic matter. So you are accumulating 1,000 pounds. Carbon-nitrogen ratio 10:1. So think about, you are not building organic matter, you are building nutrients also.
So we talked about our active organic matter being a source of energy. So what is our first source of energy? It's sunlight, right? So we start with sunlight, we have plants convert the sunlight, and now we have a system of a food web started with microorganisms that feed on plant material, the root structures, and then we build up all the different other kind of microorganisms in the soil. So we start with that conversion of sunlight with photosynthesis in the basic plant materials, both biomass and root mass, and that then provides the energy to microbes, and these are things that we need to have a good, active, and healthy soil. We have to have these things. So ideally, we like to see more fungus in the soil. That's more of a healthy type of soil. And now we do have tests that we can determine the amounts of these different ingredients, where even like 5 years ago, it was very difficult to know. Now we have that ability to actually come up with an analysis of our soils and what microorganisms they contain. So that's good to know as you change practices, you go to no-till, cover crops, and other things. You can actually track your progress and get actual numbers and counts that way. So that's good that we have that information. So we'll get in some demonstration. So how do we build organic matter? We have to be able to retain the rainfall when it happens. Because what's the worst thing to happen when you get a 1-inch rain today, tomorrow you get another 1-inch rain, maybe a week later you get another rain. Where do those later rains end up? Probably not on your field because your soils are saturated and they run off. We have to find ways to allow those extra rains to infiltrate and be stored in that organic matter in the soil. If your soil is crusted, it's not going to absorb anything, right? So we got to get it past that crust and down deeper in the soil. So what we did, we'll show you how we did it. We looked at a conventional soybean corn rotation where they used conservation tillage on rotation. And this was in early June when we did this study. Compared that to wheat, a growing wheat crop, and then to organic clover. This is all done the same day, similar soil types. And I chose organic clover because if you look at organic systems, there's a lot of tillage, right? So you think, well, they're not going to have good infiltration in organic because they're beating the soil up all the time, and that's the worst soil structure. So how do they overcome that in organic? You extend the rotation. In this case, we added the clover. So in this growing clover crop, I couldn't even time how quickly the water was absorbed. It was so fast and so good. And as you can see in the wheat, we do 2 tests. The blue line is the first test. It was a few seconds, and then it took about 16 minutes to an actively growing green wheat crop in early June. So that's not too bad. And then the first rainfall, the first inch rain, the blue line in the conventional, again took about a minute. But here after an hour, that second 1-inch rainfall was not being absorbed in this conventional system. That first 1 inch was all it could handle. After that, all that rain was going somewhere except down deep in the soil. It was going on the surface, it was causing erosion, it was taking nutrients with it. We don't want to see that, right? So what we can do, we have various ways of doing infiltration. This is one where we can pound these in the ground. This is a standard NRCS 6-inch diameter, and we can pound this in the ground, but really just take a metal coffee can, cut the end of it off, pound it down the ground. You don't have to have the exact dimensions or anything. You take a bottle of water, pour it in there. You can't see it here, but what you do is you time it. When you see all the water disappear in the soil, then you stop timing it. So once that's absorbed, you do that second 1-inch rainfall. This is the more important time, is the second time you do it. And then you time that the same way. And that's how we see, here there's not a whole lot of difference in the blue line, right? Orange line is tremendous difference. That's the important one we're really wanting to measure. So another way is checking for earthworms. So the second time I put the water in, I just put a tablespoon of mustard, and this goes down in the soil and it irritates the earthworms and they come right up to the surface. I don't have to do any digging. So it's a good way of detecting if you have any earthworms in your soil. And it doesn't hurt them, you just wash them off and you didn't kill them or anything if you're really careful about it. So you can combine the second infiltration with an earthworm count. So it's very simple to do. And like I say, as long as you have the same diameter like a coffee can, go to where maybe the tractor tires are making tracks, you know, in your corn rows, check that. Move over another row or two between the tractor tires where it's not been compacted, and just see the difference of infiltration. This is how you're going to learn how bad your soils are or not, and really what condition they are for absorption. It's very simple, there's no science really to it, but unless you start doing these things, you don't have an idea of really how well you're doing until that heavy rainfall happens and you have ponding and flooding and you lose your crop. So these are some simple tests you can do.
Alan, recently we found that the water you add, if you add a spoonful of vinegar with water, it does the same thing.
So vinegar works too.
It irritates the skin of the earthworms, so they will come up.
So the other thing besides infiltration is soil compaction. That again is a very important aspect of the soil health, because if you have very tight structure to your soil, the roots cannot penetrate, they cannot go down deep and absorb the nutrients and the moisture you may have there in that organic matter. So how many of you have tried a penetrometer? Okay, I'll just let them pass it around. What you do is just you push it down